Saxon's Calculus Lesson 6 on page 43 is about similar triangles and then functions of the negative theta. So in part A, where they start off with similar triangles, they remind you of a statement where we just learned the P double arrow Q is the if and only if. So the statement for whatever P is true if and only if Q's statement is true. So then they do a series of reminders here that have nothing to do with, well, the rules have to do with similar triangles, but not this kind of review of the if and only if. So they give you P yields Q, and it says P would be the angles are equal. So the angles are equal if the corresponding sides are proportional. So you should remember from similar triangles, which means that they have the same shape but not necessarily the same size, that their sides form proportions. Then their next statement negates that and says negative P yields negative Q. So that is, of course, the inverse, and it's saying the angles are not equal if the corresponding sides are not proportional. Then they do the converse, which is Q yielding P, and they say that if the corresponding sides are proportional, then the angles must be equal. And then finally, they do the contrapositive, which is flipping the statement order and then negating both. So if the corresponding sides are not proportional, the angles are not equal. And so that is true about similar triangles. They're just choosing to give it to you in a different format with the P's and the Q's. But in example 1, which I've gone ahead and drawn, they ask us to solve for the B by determining if these are similar triangles. Well, they both have 90 degrees, this one here and the big one overall. That is, of course, not a triangle. And so if they have 90 and they both share the corner A, then these two corners must be the same. So yes, I have similar triangles. And if I have similar triangles, I can set up proportions. And they want me to solve for the B. So I definitely need to get the B. However, B is not a side of a triangle. It is part of the big side, which would be B plus X. And what is the matching hypotenuse side on the little one? Just the X. And then I need to choose. And I would not use the C and the 4 because that would add more letters in here, and I already have 2. And so let's look for numbers that I might be able to use. The 4 matches with the C. We just said that was unhelpful. But this one, from the little triangle, it is a 6. And from the large triangle, oh good, that's a 10 by adding those two together. Now, I still can't just do my cross multiply and solve here because I still have a B and an X causing a problem. Can I figure out, well, B is ultimately what we want, but can I figure out what X is? Oh, yes, that's a right triangle. Pythagorean theorem, that's the hypotenuse. Great. So let's stop and do that. 6 squared is 36 plus 4 squared is 16 equals the X squared. 52 is X squared. So X is the square root of 52. And can I simplify that? Let's see, 2 and 26, 2 and 13. Yes, a set of 2's pulls out. So in here, everywhere I have an X, I'm going to change this to be 2 root 13. And again here, 2 root 13. Now I can do the cross multiply. So 10 times 2 root 13 makes 20 root 13 equals, and then B times the 6 is 6B, and 6 times the 2 is 12 root 13. What like terms do I have that I can put together? Well, the root 13, so minus 12 when I bring it over is going to leave me with 8 root 13 equals 6b. We're going to divide by the 6 to remove it, and of course that's not going to go evenly, so we're going to just reduce that 8 and that 6 down to 4 root 13 over 3, and I can't reduce that any further, so now I've solved for B. In example 2, same thing. I have a large triangle and a 1 at the tip here on the right. They both have 90 degrees marked. They share this angle, so the third one is implied, so proportions I can set up. And what does it want me to solve for? P. All right, so I know I need to use the bottom side of the small one compared with the length of the bottom side of the big one, and that would be d plus p equals, and now I'm hoping for something else that had just numbers, but since I don't have that, doesn't matter what set I use. Well, it kind of does. I have no information about the hypotenuse, as I can't use that. So we started with the little triangle, so we're going to pull the other side from that one, which is then x over its matching from the big one, h. So I realized my answer here when I solve for p is going to be a series of letters. So x times dp, and I could distribute it or write it with the parenthesis, equals ph, and we're solving for p. So I do have to distribute this out then because I got to put those p terms together on the other side. So we have xd plus xp equals ph. Let's move the p over, so leave xd equals ph minus xp when I move it over, and then pull the p out, so we're left with h minus x, still equal the xd. So then when I divide, the final answer is xd over h minus x, and that equals my p. Just double checking. Yep, that's the answer they're looking for. Now, example 3. This is marked with arrows on these two lines, which is my big clue that they are parallel. And if they're parallel, then this is a transversal and this is a transversal. So we just reviewed alternate interior or corresponding angles. And so this one on the inside is corresponding with this one. This angle is corresponding with this angle, so that is 2 of the angles. And the third one is the A, same in the little one and the big one. So I most definitely have similar triangles. I can set up proportions. So solving for the y it asks for. So I definitely want to make sure I have y in my equation. So from the little one, y. From the big one, that's y plus x equals, from the little one, it's a, although that looks like a d, sorry, and that is over top of b. Yep, just wanted to double check myself there. And now we're going to cross multiply. So yb equals, and I'm going to go ahead and distribute this one, ay plus ax. And then again, I'm solving for y, so these two need to be together. yb minus ay, I moved it, equals the ax, which I didn't move. Pull the y out, that leaves b minus a equals ax, and divide. So y equals ax over b minus a. And then we move on to example 4. So here is the triangle, and are they similar? Now, oh, I forgot to mark a 90-degree box here. All right, so I see that I have a 90-degree up here at the top, and then they labeled that one here as well. So I have right triangles, and I actually have 3 triangles here, one on the right, one on the left, and there's an implied 90 degrees here. It's also a right triangle, and the large triangle, which is also a right triangle. So what I will do typically on a problem where I've got 3 triangles is I will fill in a chart. Big triangle, little triangle, or no, left triangle, sorry, and right triangle, and then I will have its hypotenuse, its little leg, and its big leg. And if I organize that, then I can solve for, and in this case it wants both all 3 x, y, and z solved for. So the hypotenuse of the big triangle is 9 plus 3, 12. The hypotenuse of the triangle on the left is y. The hypotenuse for the triangle on the right is z. And then the little leg of this big triangle, it's either the y or the z. Y is the little one. From the triangle on the left, the little leg is 3. And the little leg of this one is, it's not, oh, yes, it was. Goodness, didn't label it either. It's x. Okay, try that again. Now, from the big triangle, what is the large leg? Well, that would be the z. From the one on the left, that's the x. From the one on the right, that's the 9. And now I filled in the chart with all the parts. So I am looking for where I have two different x's. Well, that would be here and here. And that lining those up would leave a 3 and a 9. So I'm basically going to ignore that part, and I'm just going to do the cross multiply here. So x times x is x squared, and that equals 9 times 3, which is 27. So x is the square root of 27. And then I can simplify that to 3 and 9, and the 9 to 3 and 3. So it gives me a set of 3's. So x will be 3 with a root 3 left stuck inside. Now I want to do the same thing and look for the y. So I've got that here and here. So I'm going to ignore the rest of it and going to get y squared equals 36. That's the cross multiply. So y equals the square root of 36, which when I simplify, that's 6. And now finally, let's do the same with z. I have that here and here, so it's a little harder, but so we don't need the info from the middle. And then I also don't need it from the middle. So I've got 12 times 9 equals z squared. So z squared equals 108. So the square root of 108 will simplify to 6 root 3. So if you want to see that work, that's 108. So I might do something like 2 and 54, 2 and 20, just a second, 14. Yes. And then 3 and 9, 3 and 3. Okay, so I have a set of 3's and a set of 2's. So the 2 and the 3 pull out. That's where they got the 6. And this 3 was left stuck inside, just to show you the work of how we did all of those answers. And then, of course, that's what we're going to box, because those are the 3 answers they asked for x, y, and z. Now, in part B, we move on to functions, and I went ahead and reminded you what the rules were that you got in trig class. And so when you have the sign of a negative theta, the negative pulls out to the front, and it's negative sign of whatever theta actually gives you. It works the same way for tangent, and therefore it is the same for each of their opposites, cotangent and cosecant. However, cosine of negative theta just drops the negative altogether and just keeps cosine of theta, and of course it's going to be the same for its opposite of secant. So now that we've reviewed those rules, they ask in example 5 for you to solve this. So the sign of negative theta we know is changing to negative sine of theta. The cosine one just drops off, so it doesn't matter anymore. And that's all over top of, and again, this negative moves out. And tangent changes to sine of theta over cosine of theta. And then I'm going to flip and multiply. So that's putting another cosine over sine, multiplying with this stuff, negative, almost forgot to move it with me, implying over top of a fraction of 1. So the sine is going to cross off, and that's leaving me with a negative times a negative, which is a positive, and cosine times a cosine, which should take me to cosine squared of theta, and that is as simplified as it can go. Now, the next example 6, I've already written out, so we're going to do the same thing. Tangent of negative means the negative pulls out. Sine of theta over cosine of theta is multiplying with cosine of theta, and the negative is irrelevant, so we drop it. And since those are multiplying, I know automatically that those cosines are going to subtract or cancel off. So then I have my negative sine of theta minus, negative pulls out, makes that plus sine of theta. So is negative sine plus sine equaling 0? Yes. And so I've basically done what it asked me to do, is prove that that statement went to 0.